Hello, welcome to FX PhD. My name is Matt Leonard and this is arn201, and in class number 2 we're going to be looking at render settings. So we're going to go through a whole host of different settings including sample, ray depth and things like motion blur, system settings and overrides if we have time. So let's begin by just having a quick look at how the samples work in Arnold. We spoke about this briefly last week, but let's really get into the nitty-gritty as to actually what's happening. Okay, so the first thing for us to talk about is samples, and increasing the sample rate reduces the amount of noise, and this is really the key to Arnold. But remember, increasing the samples basically increases the render time as well, so you need to make sure you don't push them too high, otherwise you're going to be waiting a very long time. Now the actual number of samples is the square of the input number, so if you were to type into the AA samples or anti-alias samples the number 3, they're being squared and you're actually getting 9 samples. And you probably remember this from class 1 when we briefly talked about it. Now this would be the same for the GI diffuse, glossy and refraction samples. So for instance, if we were to put in a number 2, we would actually get a number of samples being 4. Now it's important to note that the GI diffuse, glossy and refraction samples are then multiplied by the anti-alias samples, which has in themselves have also been squared. So if we had 3 in the AA samples, we know that gives us 9, and if we had 2 in, say, the diffuse, glossy and refraction, each one of those would be 4, so we're actually looking at 9 times 4, so that would give us 36 samples just from increasing, say, diffuse to 2 and anti-aliasing to 3. Okay, so this is really the key. Now if we nip over to Maya for a moment, you can see that actually we have some help in what we're looking at. So here we are inside of Maya. We're still in 2014 as you would expect, and let me just show you how the samples works. Well, over in my render settings that are over here on the right, I've just kind of put them over here just so they're kind of out the way. If I open those up and we come to samples here, you can see that we have the camera AA samples at 1, the diffuse samples at 0, the glossy at 0 and refraction samples at 0. And it tells us exactly what we're getting number wise. So we've basically got 1 AA sample and then 0 of all the others. Now if I increase the AA samples to 2, do you remember 2 will be squared, so it will actually tell us here at the top that the AA samples are actually 4, even though we've obviously set our slider to 2. Now if we go back to our diagram, if you remember we had that set to AAs of 3 and then say the diffuse set to 2, we can now see that the AA samples are 3 squared, which gives us 9, which we're seeing here. The diffuse samples are squared, so 2 squared gives us 4. So 9 times 4 gives us the 36 here. Okay, so we can now clearly see exactly what we're getting. So let's just return to Keynote and look at what happens when we increase our anti-alias samples. So you can see the diagram on the left, we have our anti-aliasing set to 1. You can see we're getting a very coarse image. And as we move through anti-aliasing samples 3, 5 and 10, you can see we're getting a much nicer, smoother image. Now let's look at what that looks like inside of Maya directly with our project for this week. Okay, so the scene we're going to be working with is actually this one, and you can find it in your main scene folder, and it's just as class 2 rendering _01. So that's what this is that we have loaded. So let's just go ahead with our camera AA set to 1, everything else set to 0. Let's just do a render and see what we're going to get. So you can see here we have quite a nice image already, but obviously it's very noisy, and that's due to the fact that our AAs are set to 1. So if we return to Keynote again, we can just see that with our AA sample set to 1, we're getting that very grainy look. As we increase them to 3, 5 or higher, that is going to really smooth out. And you can see between 5 and 10, there's actually not a huge amount of difference. So again, back in Maya, let's just take our AA samples from say 1 to 3, And remember that the AA samples of 3 is actually squared, so that's giving us 9 samples in the anti-aliasing. We're not getting any samples still through for direct, glossy, or refraction. So let's just save this and render that and see what we're going to get now. Okay, so that's gone through. You can see that that's really tidied up a lot of the noise. We still have noise in different areas. For instance, in the balloon is quite noisy, and on the surface here where the reflections and specular highlights are, which all come under glossy, they're still noisy, and we've even got some noise over in this kind of diffuse area here. But generally we've really made a difference. If we go back and forth, you can see we've gone from 9 seconds to 39, but it's made a ginormous difference. Now, even though our glossy, which is really our specular and reflection, is down at 0, we're still getting direct rays, which is why there's still some kind of shininess here, some glossiness taking place, reflections, etc. Okay, but as we increase this, we're going to be getting more and more information coming through. But let's not get ahead of ourselves. Let's go ahead and look at what happens if we now start increasing the diffuse amount. So in my slide here on diffuse, you can see that the first image basically is a room where you have one light coming in through the doorway and bouncing on this back wall. And with diffuse samples set to 0, we don't get any indirect diffuse, any bouncing of that information. The minute we set it to 1, we then get one diffuse sample that kind of comes in and bounces around, but we get quite a noisy image. And as we then increase the diffuse samples, that noise in the diffuse areas begins to get more and more smooth until we completely obviously eradicate it. So back in Maya, let's just see what happens when we increase our diffuse sample to 1. What we'll then start getting is some diffuse information indirectly, and the places to look are things like the balloon and this side wall over here. They're the places to look. So let's just come in and make sure that we've only got the relevant images we need. So let's go ahead and render again. So this is now the same AAs, 3, which is giving us an AA sample of 9 because it's obviously 3 squared. We've now added one diffuse sample, and 1 squared is obviously just going to give us 1. So we have overall 9 samples altogether. So all of a sudden you can see now that we're getting a much nicer look to the balloon. We're getting some indirect light coming in. And then as we start rendering across on the right hand side, in fact all over the image, it's just more apparent on the right hand side. You'll really see more information coming through. Now where we have our diffuse information coming in for the bottom of the balloon, you'll notice that it again appears to be quite noisy. And this noise, as you saw in the keynote slides, can be eradicated by increasing the diffuse slider, or we could increase the AAs. But increasing the AAs is going to increase everything, and we now know that probably some of this noise in these certain areas is just diffuse sample noising. So we can just increase the diffuse samples to get rid of that noise that's taking place. So we'll let this finish rendering. It looks like we're almost there, and then we'll just home on well, let's say this section of the wall over here. So I'm just going to save this, and you can see first off the difference, quite dramatically different. Not as dramatic as the keynote, because obviously we just had light coming in from outside, but even so, massive difference in kind of the quality that we're getting. Now if we wanted to, we could go further and increase our diffuse samples to say 2 or 3, and that's going to begin to get rid of any noise that we might have in those kind of diffused areas. I'll leave it on 2, but let's return to Keynote again just to look at what's happening with our glossy. So if you remember, I said you always get direct specular information coming in. The minute you increase your glossy samples to 1, you then get your kind of reflections coming in as well. So in our scene back in Maya, let's increase our glossy to 1. Remember, we've already taken our diffuse and increased it since our last render, so we hopefully should be getting rid of some of that noise. And we'll now do a render, and we should start seeing some of the reflections coming in as well. So what you're seeing here at the moment is just direct specular information. So again, let's let that render go through. Okay, you can see now with this render that again we've now got a significant improvement in quality in the areas of diffuse, but we've also now introduced our glossy rays. So you can see a massive difference in those bounce rates, especially in this section here around his eye where you've got this kind of chrome shader, and also on his belt. You can see all those rays now coming in, and we're getting this really nice kind of glossy information for the reflections. Now, the balloon itself is still a little bit noisy, and we may even say that some of the refraction is noisy. So that can obviously be smoothed out by increasing the number of samples for the refraction and subsurface scattering of the balloon itself. So if we go across to Keynote again, we look at refraction, you can see with our refraction sample set to 0, we don't get any refraction rays, and therefore we don't actually see anything through our object. When we set them to 1, we get a kind of a noisy refraction taking place, and as we increase it, that noise obviously reduces. So again, back to Maya. Let's increase our reflections to say 2 and our glossy to 2, so it'll mean that we'll get slightly smoother kind of reflections, specular information, and also obviously our subsurface scattering needs to have some information increased as well, so we could put that up to 2 as well. So if we just grab the balloon and I render that, you'll be able to see a significant difference straight away. Okay, so that's finished, and you can see big difference there in the quality of the noise that's gone. And then with our refractions increased, we're going to see nicer information in our refractions as well, especially if we decided to blur some of those refractions or blur some of the reflections. So again, if I just go back to my attribute editor, let's grab one of these, come across to our refraction here. We have the color, the weight, the index of refraction, and the roughness. Let's just increase our roughness just a little bit to say 2. Again, we're just going to come into here, come back to our settings, put our refraction down to 1, and just render that. And then we'll increase our refraction samples, and we'll see that refraction smoothing out, removing some of that noise. Okay, so you can now see we've got a nice blurred refraction, but it's very noisy. And as we increase the refraction, say to 2, again, let's just take half of this so you can see the difference. Render again, you're going to really begin to see that smoothing out. So you can see that now just finishing off, and the increase in samples has really made a big difference in the number of rays that are being fired, and therefore the smoothing or just the cleaner, less noisy image we're getting. Okay, so I'm going to set probably everything as is. What we may choose to do is just increase our camera anti-aliasing now to 4, which is increasing everything. Everything's getting times up by this. So once you think you've got everything to a reasonable level, and you think everything's now just a little bit noisy and I want to now reduce the noise across everything, that would be the time when I find that increasing the AAs is the way to go. Okay, so we've got glossy on 2, we've got diffuse on 2, we've got reflection on 2, and we've got subsurface scattering on 2. I'm going to take my roughness of my glass down a bit. I don't want it quite that blurry. Now, one of the other things that we need to be aware of is shadows and the samples that we're getting from our lights. Now, at the moment we have a light on his hat that is kind of shining down onto the balloon, and that has a sample count, and we may find that there are shadows coming from this which are a little bit noisy, and they can be increased in their ray count or sample count by increasing something directly on the light itself. So if I come to robot, lamp, and light, on here is the spotlight shining on the balloon, and you can see this has a sample count of either 0, or you could begin to increase that. So if I put my samples at, say, 0, also I have ambient light, which is my sky dome, which is doing general ambience. That again has a sample count, and let's say we're going to increase that to say 3. My key light, which is coming from kind of up on the top left, shining down this way, which is casting my shadow on the floor, that's quite noisy, and again that sample count could be increased to say 3 as well. So let me just go back to my headlight. In fact, having set it to samples of 0, let's actually put it to 2, because we're not really seeing a lot of shadow from this. It's probably here or maybe just out of shot, but it certainly doesn't look too noisy. So I'm only going to have the sample set to 2 for that. So we've now increased samples on our lights. We've also increased samples directly here in our render settings. So what I'm going to do is now is render this, let this go through, and let's see what the final image looks like. Before I do that, I'm just going to save this out as 02, and I'll do underscore samples. So that's what we've been affecting with this one. So let's let this run through. Okay, so the render's finished. It took about 7.5 minutes, and you can see it's now looking really nice. Maybe the only thing we might want to do is increase the subsurface scattering from maybe 2 up to 4, because this is still looking a little bit noisy, the balloon, and I know that's the only thing that has subsurface scattering in it with regards to material settings. So I've just taken the liberty of increasing that to 2. Now the next section for us to look at is this ray depth. So before we get into that, let's just move across to Keynote again and just have a look at what that's all doing. So the ray depth basically is limiting the bounces, or the ray bounces. So we've got various options here. Firstly, we have diffuse ray bounces, or ray depth. 0, we're basically limiting it to nothing. As we increase the ray depth amount, we get more of those rays bouncing around, and therefore we get a lighter scene when it comes to our diffuse. Now the next one is glossy, and this defines the maximum number of times a ray can be glossily reflected, and scenes with many glossy reflective surfaces may require higher values in order to look correct. So you can see the one on the left has got glossy ray depth set to 0, and as we increase that up to 3 in this instance, you can see more of those glossy reflections taking place. Then we have our reflection ray depth, and this defines the maximum number of times a ray can be reflected. So you can see when it's set to 1, we literally just get 1 reflection, and in this scene we're basically seeing a mirror. So you've got this donut reflected in the mirror. Behind the camera is another mirror, which is what this black area is. You can kind of see behind. As we increase our reflective ray depth up to 10, you can now see that we have multiple bounces. Okay, so that's very similar to the settings you'd have in mental ray. Then we have our settings for transparent ray depth, and this again is the number of bounces allowed for transparency hits. So with 0, objects will be treated as opaque, and as we increase that value, you can see that more and more rays are able to penetrate through the surface until you get an entirely translucent set of materials. You also have, though we haven't covered it, refraction as well, and this is the number of times the ray can be refracted. And just like the reflection or opacity, if you don't have enough rays, then you basically end up with black in your image. So let's just turn my samples down back in Maya here to 1. I'm going to turn all of my samples down to 0 for my ray depth, so all of those down to 0. Just save this image because we like it, and do another quick render with everything down at 0 in ray depth. And what you're going to see is that there's going to be quite a big change. Now I've actually left transparent depth up at 10. We could drop that down again, but it'll be fine for this example. So now all of our glass has gone black, and it's gone black because we now don't have enough ray depth bounces to get the rays through all of these. If I was to increase it to say 1, and we do just a render of this bottom section, so we're actually getting a 1 ray through, but it's hitting the back of the object, and we're now not seeing through again. So we need to go to 2, and we should get through the first object, or at least the first surface, without any intersection of one glass material on top of another. You can see where they do intersect, or where you do see one behind the other, it remains black. So that's why you're getting these black areas. So you end up having to count up how many you think you're going to need. I know 10 definitely does it. So if we render that again, we should now have removed any dark areas. And what's nice is increasing this sometimes doesn't increase the render time dramatically. You can see we're still getting quite a good render time. Now if I drop down to 8, let's see if it still renders through. And it's well worth adjusting these until you're getting exactly what you want. One of the things that you often see people do who are new to rendering is just kind of wham everything up full blast, and that's obviously may solve their problem, but will also increase their render time. So you definitely want to be careful. So refractive value at 8 still worked. Let's try 7. 7 still looking good, so I'm guessing probably 6 is the number. We also have obviously reflection, and that's going to give us multiple bounces off of our objects. So I tend to find that 2 is a good value. Any more than that you may not notice it. We then have our glossy. So again, 2 seems to be quite a nice number. It's going to make quite a difference. And our diffuse bounces, well, 1 will certainly make a big difference, and 2 again is going to make things look quite nice. So let's just do a save this and do another quick render. Remember that we've got these black ones here, so they are going to be quite different. If we just render this, we should now see what those additional controls have given us. Remember, our camera AAs is set to 1, so we're still going to get a very noisy image, but we now know that everything's set, and we can just pump up the camera AAs back to 4, and we're going to now get a really nice image straight off the bat. So you can see now all of those extra ray depth bounces, diffuse, glossy, reflection and refraction are really coming into play, and we're getting a really nice result. So I'll let this render through, and then I'll render one with everything set to 0 again, and render that just so you can see the difference from the settings we've currently got, 2, 2, 2 and 6, and what they look like based off of the values being set to 0. Okay, so there's our render with them all set to 2, 2, 2 and 6, and then there's our render with them set to 0. So you can see a big difference in reflection, glossy, refraction and diffuse. Okay, so we'll leave everything in this current state. So next up, very quickly, we need to look at motion blur. And we basically, when we enable it, we have motion blur based on deformation, cameras, and we can then also define things like the length of the motion blur, and that then shows you the conversion into degrees. So 0.5 gives us 180. And you can also adjust where the motion blur takes place, center, at the start of the frame or at the end of the frame. Okay, so very similar to other renderers that you would have seen with regards to the quality. The overall quality of the actual anti-aliasing itself is based off of the camera AAs. So this is the value you're going to want to increase to make your motion blur look nice. So let's just do a very quick example. We'll take our robot and we'll just drop him onto the floor, or slam him down onto the floor very quickly. So let's bring up the time slider. I'm going to just move this out of the way. Let's set a key with him on the floor, and at frame 10 let's just lift him out of shot. So somewhere like there, he should be well out. So there we go, and right click, set keys. As you can see, there's him flying out of shot. Let's just call up our animation editor very quickly and just add a bit of oomph, him leaving. So breaking the laws of physics, we'll just get him to fly straight off at a linear speed. So he's just going to leave at a straight speed, really just because we want to get some of that motion blur in. That's the only reason. We are also just going to leave everything else as is, come back to our render settings, and for the time being I'm going to just turn these values down to a value of 1, because that will just speed up the render. I'm going to leave my camera AAs at 1 again, and let's just do a quick render, and we know it's going to be based on this kind of area of the scene. So let's just render that now. So all we've really done is just switched on our motion blur. You can see there he goes, and there we're beginning to see some motion blur take place. Now we know where he is in scene. Let's just grab the bottom section. Let's increase our AAs to say a value of 4 and do a re-render. Now if you don't have any deformation of your objects, and this is where you might have like a bend deformer or something where the geometry is actually changing shape as opposed to just moving, you can then turn this deformation off. So I may do that in a minute. And you can also turn off the motion blur for the camera if you want. So in our instance, the only thing that's actually moving is just the object itself. So we could turn off deformation and camera if we wanted to. So now you can see we're getting a much nicer result. I'm going to turn off deformation, I'm going to turn off cameras, and let's just render again all of this section. And while it's rendering, let's just talk about what keys do. Well, keys are basically the number of sub-steps used for motion blur, and they can be set in this key attribute area here. Okay. Now for situations where there is direct motion, such as translation or rotation with a constant speed, often 2 keys are going to be just fine. However, if an object moves erratically, you may need to increase the number of keys. So 2 is often a good amount, but if you're finding that erratic motion doesn't look correct, then do go ahead and increase those number of keys to a higher number, obviously dependent on how much motion you've got in the scene. Now as this frame just finishes up, be aware that if you find that the motion blur is too noisy, which it may still be at this point, you're going to need to increase those anti-aliasing samples up even higher than 4 or 5. If you're doing that and you found that actually before I put the motion blur on it was all looking great at anti-aliasing of say 4, if you were then able or needed to push the AAs up to say 5 or 6, you may then say, well, the diffuse glossy reflection of subsurface samples I can then decrease slightly because I'm actually having to increase the AAs based on something like the motion blur. And this concept of needing to increase AAs for something secondary like motion blur also applies to depth of field. Depth of field, the blur quality again is controlled directly by the camera AAs. So that's another reason why this may need to be increased. Okay, so from here let's just drop him back down to the ground. I'm going to turn off motion blur and I'm going to put my AAs to 5, diffuse 2, glossy 2, reflection 2 and subsurface scattering 4. Okay, so let's just close that motion blur, leave everything else as is, and let's just jump across quickly before the end of the class to look at some of the system settings and some of the overrides. First off, we have this progressive refinement, and this is the image being rendered several times with increased AAs as we put on the IPR. So if I put on IPR in here, IPR on the camera, you'll see what's going to happen is it's going to run through and it's going to gradually increase the quality. So there it goes. So it's getting better and better, and we can stop that, pause that. If we turn off progressive refinement and put the IPR back on, what it's going to do is just start rendering normally without that kind of continual updating. So I'll put that back on progressive refinement, hit IPR again, and we'll now see it kick into life. While we're waiting, we've got this initial sample level here, and this is the initial AA samples used for the first progressive render. So negative values, as we've got at the moment, are sub-samples of the render, and they allow faster feedback. Okay, so that's why that's set at a default of -3. Next up, we have this bucket spanning, and we've got various ways: top, bottom, left, right, random, woven, spiral, etc. So at the moment you could see that it basically, when we render, it just renders kind of from the middle in a spiral, and that's based off of this amount. So you watch it go through, you can see it kind of spiraling out from the middle. If we set it to something like bottom and re-go, you'll see it's now going to work up from the bottom upwards. There we go. Okay, so again, let's just stop that. I personally like spiral, but you can have it on anything you want. It doesn't really make much difference. Then we have bucket size. This is the size of the image buckets. The default is as it's set, 64 by 64, which is a pretty good compromise. Bigger buckets use more memory, and smaller buckets may render slightly slower, but give initially faster feedback. But I tend to leave it on 64 by 64. Everything else I wouldn't really mess around with. It's a pretty good setup just straight out the box, as you would expect. Now the final thing that I just wanted to talk about is overrides here. This can be really useful for debugging if you're doing things and you're just trying to work out what's going on. You can do things like ignore certain areas of the script. So for instance, we could ignore things like shaders. So if I switch on ignore shaders, you could also do things like ignore shadows. And the reason why this has suddenly done this is because it actually was rendering in the background. So I could switch on shaders again, and we'll see the shaders, but we won't see any shadows because we've turned those off. This is a good one, ignore subdivisions. If I do that, anything that's running on nice smooth subdivisions is now basically just going to render in its original form. You can do things like ignore motion blur if you've got motion blur on, ignore depth of field, subsurface scattering, which again I can turn off. So all of these are quite nice. If you've set your scene up, you're happy with the quality, you don't necessarily want to adjust the sample size, though you may choose to, but then you also may say, I'm just going to now turn off shadows, turn off subdivisions, turn off subsurface scattering, whatever you might choose to do. Okay, so that's what this does, this kind of feature override. Really useful and just a good way of getting everything to run a lot faster. So again, let me just ignore shaders, and again you can see that we end up with just a white outline there. Okay, so switch everything back on and we're now ready to go. Okay, so that really brings us to the end of the class. I'm going to just render this image out at a high resolution so you'll be able to see it in a moment, and that can be rendering in the background. But before we finish up the class, there's one thing I wanted to show you that you're going to find really useful. That's this document, Removing Noise. This is off of the Solid Angle website. It's incredibly useful, and the reason why I've given it to you as a PDF is just because I don't know if you have access to it. I'm sure Marcus and the guys over at Solid Angle won't mind me sharing this with you, just because it's such an important and useful document in we're looking at noise and removing noise. The really useful part of the entire document is this initial image here that you see. This just shows you all the areas where you're going to have noise and it just shows you it very blatantly, so you can very clearly see, okay, this is the indirect noise, this is the subsurface scattering noise, this is the shadow noise, and then the document really goes through and just tells you how to fix those issues. Okay, it also has a little bit, as you can see here, just on AOVs, but we're going to be getting to that in our class with regards to using AOVs around about class 7. But a huge amount of useful information in here to do with all things relating into noise. So I've just given you that just in the download file, along with all the other bits and pieces for this class. So I hope you've enjoyed the class. I've certainly had a great time going through everything. If you have any questions, of course, put them in the forums and get those answered straight away, so that you can continue and get your renders looking really nice. As you can see, I wasn't bluffing on the first week. Everything in making things look nice in Arnold really comes down to just dealing with the noise, dealing with the samples, and hopefully through this week's class you've now got a much better understanding as to how they work and how you can improve your renders without making the render time ridiculously long, just by cranking everything up to the max. Next week we're going to be looking at lights, so we're going to be looking at physically plausible lights, we're going to be looking at image-based lighting, we're going to be looking at how we can work with exposure, degrees Kelvin, also things like photometric lights, what do they do and why are they useful, along with bits and pieces such as barn doors, gobos, and various other things that we would expect to have in our lights. So until then, as always, this has been Matt Leonard for FX PhD.